On PSC1-3, we'll go through the similarity shortcuts that we will use in this unit, and then we'll also talk about using those shortcuts to find missing lengths and angles. So the first kind is angle, angle, angle similarity. If you have two angles of one triangle congruent to two angles of another triangle, then the triangles are automatically similar. Which makes sense, because if I keep these two angles the same, then I know the third angle will automatically be the same because I can subtract from 180. And even if I stretch this out, everything is staying proportional as long as those angle measures stay the same. You can use just angle, angle similarity. I tend to use all three letters, but you can use just two. I just like using 3 for all of them. My next one, side, side, side. If all three sides are proportional to 3 of another triangle, then the triangles are automatically similar. So if I have something like this is 2 and 3 and 4, and then I have another triangle where this is 20 and 40 and 30, I know they're going to be similar because 2 over 20 is the same as 3 over 30 is the same as 4 over 40. And our last one is side, angle, side. So if I have two sides proportional to two sides of another triangle, and the included angles are congruent, then the triangles are automatically similar. And what we mean by included angles is it's right in the middle. If you're included with your friends, that means you're with them. You're right in the middle. Okay, you're not left out. In a triangle, if I know this side and this side, it's the angle between the two sides. So let's say I knew these were congruent, and let's say I know my sides are 7 and 10 here, and then I have 14 and 20 here. Well, since I've got the angles congruent and the two sides touching both are proportional, I can use side, angle, side to prove that they're similar. We're going to practice this a little bit. I'm going to do some color coding. So I've got L to M is my longest side here. 14 to 7 is half. MN is my medium side here. My medium side here, 12 to 6 is still half, so those are proportional. I'll use yellow and green. My shortest side and my shortest sides are also half. Since all those proportions worked out to be 1/2, I know that these are in fact similar. LM was my pink side, so SR will be my first side there, and I'm going to switch colors. And then MN was this blue side, and I used RN for that one. The shortcut I used was side, side, side. On this next one, I have a 59-degree angle and a 59-degree angle. Wonderful. This side LM is twice as big as QR. This side 14 is twice as big as QS. So I've got side, angle, side, because I have two sides and the included angle. QR is that green side. LM is the green side in this triangle. And then RS was the uncolored side, and MN was the uncolored side in this triangle. On this next triangle, I've got some parallel lines. This is going to act like my transversal, so I can get this angle and this angle. I can also get my vertical angles. And then for the same reasoning, if these are my parallel lines, this could be my transversal. And so I've got my alternate interior angles again. I only needed to find 2 of those because once I've got 2, I've got all 3. But having all 3 just makes it an even stronger case. So I've got angle, angle similarity. I could do the third angle if I wanted, if I like using all 3 letters. Oh, and that's not what I wanted to put it there. We'll put it over here. By angle, angle. The third angle is optional. And I'm going to match up my colors here. So angle S was my blue angle, so that's going to go last. Angle, T was my purple angle. In my other triangle, that was Q. And angle U was my red angle. In my other triangle, that was R. So UTS corresponds to RQS by angle-angle similarity. On this one, I've got QRP. So QR. And I'm looking at this and I see, hey, this guy could correspond here and have this guy correspond here. So it could be folding across. Or I could have the 30 in this one corresponding and this corresponding. So this one's a little ambiguous. Either way though, because I've got these vertical angles, I know I'm using side angle side. If I choose to use that red and blue triangle, so if I'm looking at it as this side and this side match up and my triangles are kind of folding in on each other, when I've got QRP, that'll match up with, QR will match up with EF, RP will match up with FP. If I picture it as my triangles are kind of twisting around, so if instead of using those, I'm thinking of this triangle here is rotating around and getting bigger, then I could say, let's see, QR would still match up with EF, but instead of having RP match up with FP, I would have it match up with EP. So I would want to do F, E, and then P. This is the one that most of you will choose because it's easier to see, but you could also put it in this way. All right, I've got a small triangle here, and then I have a second triangle here. That red and that blue triangle both have angle N in it, and they're in the same spot. And then they both have this 82-degree angle. So I've got angle, angle, third angle if I want it, similarity. This side, LN, or LM rather, corresponds to UV. And then just to make sure, MN corresponds to VN, and it does. So I can scoot that N over so it looks a little neater. On this last piece, I'm going to check to see, I've got my vertical angles here. So I'm tempted to say, ooh, it's side angle side. And I've got 5 over 30. And then I've got 8 over 35. And if those are equivalent, then I can use side angle side. 5 over 30, if I throw that in a calculator and get a decimal, I get something like this. 8 over 35, and it keeps going. These aren't equivalent fractions, so they are not similar. When I can't determine that something is similar, instead of saying, nope, they're not similar, I'm instead going to say it cannot be determined because I'm fancy. And I'm going to leave it just like that. All right, on this example, I'm not told necessarily that these are congruent, so I don't have a way of just automatically matching, or similar rather. So I don't have a way of automatically matching them up. So I need to do a little thinking first. D is half as big as AB, so is C. So those angles will match up. And then I've got vertical angles here. That means X is between the red and the blue angles, so is 7. 8 is between an uncolored angle and a blue angle, so is 6. So my triangles are folding in on each other. And I get 6 to 8 equals 7 to X. I'm going to multiply by my denominators on both sides. 8 drops out here, my x drops out here, and I get 6x equals 7 times 8, which is 56. And when I divide, I get 9 1/3 for x. On this next example, I've got parallel lines here being cut by 2 different transversals. So this angle and this angle will correspond. This angle and this angle are also alternate interior angles. And then I'll have those last angles in the center. So my triangles are kind of twisting around, if I can picture it, flipping up. So the 12 and the W match up, 9 and 15 match up, and X and 21 match up. So I'm going to start with 9 to 15 equals the same thing as 12 and 9 are in the same triangle, W and 15 are in the same triangle, and then I'm multiplying by my denominators on both sides. My 15s divide out, my W's divide out, and I get 9W equals 12 times 15, which is 180. When I divide by 9, I get W is 20. I'll repeat that same process to solve for x now. We've got 9 to 15 equals the same thing as x and 9 are in the same triangle, 21 and 15 are in the same triangle. I'm going to multiply by my denominators on both sides. 21 divides out, 15 divides out, and I get 21 times 9, 189 equals 15x divided by 15, and I get 12.6 for x. On my next example, solving for x and y, I've got a smaller triangle here, and it's going to be similar to this triangle here because I've got the parallel lines. So I know this angle and this angle match up, and then they both have that angle. So I've got angle-angle similarity. This means that 4 corresponds to 4 plus x in the same way that 5 corresponds to 11. So I can do 4 to 5 equals 4 plus x to 11, and then I can cross multiply and get 20 plus 5x equals 44, which means 5x equals 24, which means x is 4.8. Similar idea with y. 4 to y has to equal the same thing as 4 plus x, which we just said was 4.8, to 8. Again, I can go ahead and clean this up. 4 plus 4.8 is going to be 8.8. I'm going to multiply by 8y on both sides. My y's divide out here, my 8's divide out here. 8 times 4 gives me 32 equals 8.8y. Divide by 8.8. I get some crazy numbers for y. I'm going to call this 3.63 repeating. On my last example, because I've got that right triangle and then they both have this green angle, I know that this small purple triangle is going to be the same as this, or similar to this larger blue triangle. So 5 will correspond to 30 in the same way that 13 corresponds to 13 plus x, and I'm going to find my cross products here. So 13 times 30 is 390. 13 times 5 is 65 plus 5x. 390 minus 65. 325 equals 5x. Divide by 5 then. And x must be 65.